morning, students. I am Krishna Rao, Assistant Professor, CSE Department. I am handling the compiler design for the 5th semester. So, in previous classes, we have discussed with the SLR parsing methods, CLR parsing methods. Now, in today's class, we will discuss the lookahead LR parsing method. Right? So, here we will discuss the lookahead LR parsing method. Here, this lookahead parsing method, it will be the smaller parsing tables than CLR or LR1 parsing tables. The number of states in SLR and LALR parsing tables for a given grammar will be equal. CLR parsing table have 10 states. Then LALR parsing table will have less than or equal to LALR. Here, the resultant LALR states will be equal to our SLR parsing table. Now, here LALR parsers recognize more grammars than SLR parsers, right? So, at another compiler YACC, creates the LLR parser for the given grammar. A state of LLR parser given again a set of LR1 items. Simply, the construction of the LLR parsing table or the construction of the closure groups in LLR same as CLR, canonical LR. Here, after constructing the canonical LR closure groups, we'll check the productions in the group in another group are the same or not. If the productions are in different groups are the same, but lookahead symbols are different. Lookahead symbols are different. Then we combine both the closure groups. Is it clear? Group 1 and group 10 have the same productions, but the lookahead symbols are different. Then the LALR says that combined the group 1 and group 10, combine the union of the lookahead symbols. So, will result to the less number of states in the LLR, right? So, canonical LR parser shrink the number of states will result to the LLR parser. So, to construct LLR, we must construct canonical LR. After completion of the construction of the canonical LR, then we combine the groups which have the same productions with lookahead symbols are different will result to the LALR parser. Here, this combining may reduce conflict, but it will not result shift reduce conflict. This combining of the groups may result reduce conflict resulting LALR parser, but it cannot produce shift reduce parser. But after constructing the LLR parser, there is a conflict, if there is a conflict, reduce conflict, then we say the grammar is not LALR. After combining the groups also, it should be free from shift reduce or reduce conflicts. Then we say the grammar is LALR. Then we say the grammar is LALR. Right? So here the code of a set of LR1. So we said the word the production is same, but here we simply say the word code of a set of LR1. So here in this one, these productions will refer as code, right? Will represent as a code. If it is the same between two groups, then we combine the groups and also we union the locate symbols will result into the new group, right? If you observe here, this is I1, this is I1 group, this is I1 state, this is I2 state. First one I1 and another one I2 state. Both have the same code or same production, but the locate symbols are different. The locate symbols are different. In canonical LR parsing method, this I1 and I2 both are different states. Both are different states. But in LALR, in look ahead LR parsing method, will combine these two states will results to the I12 state. We are combining the both the symbols. We combine but the both the symbols as simply assignment followed by $sign. So we can write that both the productions or we can combine them, right? Which results to the LALR parsing method, bottom up parsing method. So is it clear? To construct LALR parsing table, we must construct the canonical LR closure groups and go to operations. From that, we find and will combine the groups, states will results to the LALR. Look at LR parsing methods. So will results to these new states here. Okay. So that is the reason the number of states in look at LALR will be less or equal to CLR parsing method. So we will do this for all the states of canonical LR1 parser to get the states of the LALR parser. So we will verify all the states of the canonical LR1 parser to get the states of LLR parser. To get the states of LLR parser. In fact, the number of states of the LLR parser for a grammar will be equal to the number of states of SLR parser for the same grammar. So, next, creation of the LLR parsing tools. So, first step, if you observe, create canonical LR1. Create the canonical LR1 collection. Create the canonical LR1 collection of the sets of LR1 items for the given grammar. Right? Create the canonical LR1 collection of the sets of LR1 items for the given. That is the first step. To construct LR parsing table, the first step is to construct canonical LR collection of closure groups as sets. Right. Then for each find the core is same or not. Find all the sets. Find all sets having the same core. And finding them combined all the same core states. Right? The union. Okay? Combine the union. Here, C equal to I naught to In, and results will give to J1 to Jm, where M less than or equal to N, where M is less than equal to N. C equal to I naught to In, and the resultant combining the state will result to C dash. So J1 to Jm, where the Me will be always less than equal to N. Right? The create of the parsing tables, action go to tables, is the same as construction of the parsing tables of LR1 parser. Right? The construction procedure for the LLR parsing table will be similar to canonical LR parsers. Similar to canonical LR parsers. So here note that if I equal to union of I to K, I have the same core. So wherever there is a go to operation, I1x to I2x must be the same. So all that I1 to Ik, now we have combined it. So after combining, so any state go to operation results to the same. Right? Then it must be free form. Reduce conflicts or shift reduce conflicts. Otherwise, we can say it is not LL1 grammar. So here, shift reduce conflicts. By combining these states, it will not result to the shift reduce conflicts. What is shift reduce conflict? So here, this is the reduce action will be taken. For this one, if A is an input, then shift action will be taken. Right? So, it must be here. If we say the same code will be different terminal symbols. So, you say here they will be A only, but here it is C. But already it is a shift reduce conflict. So, the version canonical LR1 parser has a conflict. So, simply we say it is a CL, it is not a CLR also. So, it cannot be LLR. Right? So, reason for this shift operation does not depend on the gates. Right? Reduce conflicts. Right? So, here in this reduce conflict, production of this one on symbol A, production of this one on symbol B. There is another state, there is a conflict that this direction on B symbol, this direction on C symbol. Now what do you say? The core is the same, right? The core is same. So simply you say combined of them. So which results to the reduce conflict. So which direction has to take, right? Here it is a B. Here also it is a B. Both the productions also in the same group. In the same group, the both productions are there. So we have to reduce one of the production, but for the same symbol, for the same input symbol, there is a confusion. There is a conflict. Reduce conflict. For the same input symbol B, which production has to be reduced? The first production has to reduce, or the second production has to reduce? That is the conflict. Simply we say it is not the LLR grammar. So to construct the LLR parsing table, the first step is to construct canonical LR. The first step is to construct canonical LR. Right? After constructing the canonical LR only, we check which productions of the groups are the same, which symbols are the different, so that we can combine the particular states. We can combine the particular states. So it results to the look ahead LR parsing. Right? So first we'll discuss, right, construction of the canonical LR. Then we continue to discussing the construction of the LLR parsing table. Now this is the given grammar, right? This is the given grammar 1 to 5. Then the first step, add a special production. Add a special production, right? Right? Add the special production. S dash use S. Now, the first I0 group, for the first I0 group, S dash use dot S. And to find the symbol, we have to consider follow of the S dash dollar, which results to the dollar sign. Remember that always it will be the dollar sign. The dollar sign is an end mark for the input. So when you consider the follow of the S dash and dollar sign, so it will resist to the dollar sign. Dot S, since dot S add S production. Since dot S add S productions. Right? Dot S, so S production. Then what is the, how to find the symbols? How to find locate symbols? To do this locate symbols, we consider first of beta A. What is the first of beta A? This is beta, this is A. Okay, we are doing for this now, right? For this is beta in this case. We are not expanding. So for S, here beta will be the epsilon from this one. Here A will be the dollar sign. So it will be the dollar sign. First of epsilon dollar is dollar, so simply it is just to the dollar. So for the both productions, it is a dollar sign. For the both productions, it is a dollar sign. Okay. Then, is it clear? Now, dot followed by L. So, we have to add L protections. Dot followed by L. So, we have to add L protections. Then, what is the lookout symbol? First of beta A. First of beta A. So, what is the beta here? First of beta A. What is that beta? We are expanding L, right? We are expanding L. So, this assignment R is beta and this dollar is A, right? So, here, first of beta, we have to consider first of assignment or dollar, which results to assignment. So, for these two productions, this assignment is added. Only the assignment only added. Right? Is it over? Now, dot R. So, which results to add R production. Which results to add R production. For this one, what is the first of beta A? Epsilon and dollar sign. So simply dollar sign. Simply it is a dollar sign. Okay. First of beta A is epsilon dollar. It's simply dollar sign. Okay. Now is over. Now from this one dot L. Dot L. So once again you have to construct these two productions. You have to say L equal to dot multiplication R. L equal to dot ID. Then what is the symbols? First of beta A. First of beta A. For this one, first of beta A, where this is epsilon, this will be the dollar from this production. From this production, this is the first of beta A, epsilon and dollar. So that is the reason we added this dollar here. So instead of writing the productions, L productions two times with two different lookout symbols, we have written once. We added the both symbols dollar sign and assignment. So we have added dollar sign and assignment. Okay, is it clear? So finally our I naught group is completed. In this I naught group, there are 5 symbols are followed by terminal symbols. Capital S, capital L, capital R, terminal multiplication, terminal adding. Terminal multiplication, terminal adding. So here on S, dot S becoming as S dot. Dot S becoming as S dot. So dollar dollar, there is a single statement. So dot at the end. So no need to add any new productions into this closure group. That is a closure operation. Next, on L. L has two productions. Here it is L dot L. Here it is a dot L. So add both of them here. That is I2. On R, there are two productions once again. No, there is only one production, right? This is I3. Dot R become as R dot. Dot L become as L dot. Right? Then dot s become as s dot. Now multiplication. On multiplication, multiplication dot r. Since r will result here. Dot l so will result here. How to find that symbol? Simply first term beta a, beta is epsilon, a is dollar and assignment, so will results to dollar and assignment. So that is the reason we added dollar and assignment for all the productions. Okay. So dollar and assignment simply added for each production. Now there is another one, that is ID. So on ID, what happening? L gives ID dot. Dot ID becoming as ID dot. Okay. Dot ID becoming as ID dot. So here, this is the hyphen. So I0 group has 5 go-to operations on 3 variables and 2 terminals, will resulting to this one. Now I1 dot and, so no go-to operation. I2 dot followed by assignment dot followed at the end. So there will be only one assignment one that goes to the I6. Right? Here it is a I6. Dot R, so add R production. Dot L, so add L productions. Right? So I6 is complete. I6 is complete. Now I3 dot at the end. So no more productions. Then I4 dot R dot L dot multiplication dot ID. So on this, all these symbols, it going to these states. I7, I8, I4 and I5. Right? Then what is I5? Dot at the end. I5 is dot at the end. Okay? I5 dot at the end. So simply we says that there are no go-to operations. So I6 is over. I6 is here. It has dot followed by all. So there is a on all. Dot followed by L. It is on L. Dot followed by multiplication. They must be on multiplication. Dot followed by ID. They must be on ID. It going to I9, I10, I11, I12. Now we'll see one by one. Then here, what is I7? Dot R will becoming R dot. Right? So from this one, we are writing here. Dot is at and. So no more addition of the closure productions. So the group is completed. The group is completed. Then dot at the end is over. Then what is I8? Dot L will becoming L dot. Dot L will becoming L dot. So I8 is completed. Then on multiplication I4 means it is a recursive, because we get the same production and we get the same lookout symbol. So we are writing to same group. Then it goes to I5 on ID. On ID it goes to same ID, it goes to the same. Okay. Okay, is it clear? Then what is ini? Dot R as R dot I9 is completed. What is I10? Dot L as L dot. So I10 is completed. Then what is I11? Multiplication. Multiplication. What is I11? So dot multiplication as multiplication dot. Okay. Is it clear? So dot multiplication dot R. So once again R production dot L. So once again L production. Simply find out the locate symbols. The I11 is completed. On ID dot I12 also completed. Then dot and dot and dot and. For this only they will be I13, I10, I11, I12. Right? So on L will go here. On ID will go here. On multiplication will be the same. On R is going to here. This is the I30. The construction of the closure groups is completed. The construction of the closure groups in canonical LI is completed. If we observe this I4 and I11, I4 and I11, this I4 and this I11, both productions are the same. The core is the same. But here, dollar and assignment is the locate symbols. Here, dollar is the symbol. So we can combine I4 and I7. Then I5 and I12. Dollar is I5. Right. Here, this is I5. Dollar and assignment is the symbol here. I12. Dollar is a symbol here. Production is the same. Locate symbols are different. So we can combine these both the groups I5 and I12. We say here this is I411. This is I512. Next I7 and I30. This is a locate symbols. Here it is a locate symbols. Production is the same. Locate symbols are different. So combined here. This I7 and I30. Next I8 and I10. Here this is a I8. This is a I10. The production is the same. Locate symbols are the different. So simply we say I8, 10. By combining these closure groups, we'll getting as this one. 411, 512, 713, I10. So we deleted 10th group, 11th group, 12th group and 13th group. 4 states are reduced. 4 states are reduced. The same previous problem only. But that I4 and I11 states are combined. I5 and I12 states are combined. I7 and I13 are combined. I8 and I10. Both the groups are combined. So which results to less number of the states in the LALR. So in the LALR, there will be less number of states. Right? Construction of the table will be the same as previous. Right? Here, what are the states here? I10 to I9. Right? So simply we say we are adding 0 to 9. We are adding 0 to 9. Right? Now, tell me, I not group go to operations on as going to I1. On as is going to 1. Similarly, canonical LR, we are constructing the LR parsing. That is only the different. Right? What's here? I not on as going to I1. So go to operation. In go to operation, on variable as simply writing 1. Next, I not on L going to I2. So on L is going to 2. Since it is a variable, we are writing in the go to operation. Then I3 on, okay, this is I3 I not on R going to I3. On R it is I3. Okay. In the go to table, in the variable column R, we are writing the number. Then on terminal multiplication going to I47. On multiplication shift 4. Simply we are writing shift 4 because we have deleted the 11th state. Then on ID going to I51. So simply we are writing as S5. Simply we are writing as S5. S4 and S5. 1, 2, 3, 4, 5. Okay. Now 1. What is the state 1? The state 1 is special production. The state 1 is special production. Right? Dot at the special production. Simply we says 1 and accept. 1 and dollar is simply accept. 1 and dollar is simply accept. 1 and dollar is simply accept. Next, I2. Next, second state. On assignment. On assignment going to I6. On assignment S6. A reduction is there. What is the production number? 5. What is the symbol is? Dollar. So dollar reduce R5. Okay, reduce R5. Then I3 dot at the end. Production number is here third production. This is the third production. Dollar is a symbol. So $3 R2. Right? Second production dollar place we are writing reduce the production number. Right? Now fourth one. The fourth state, what it's saying here? Fourth state on R I7. On R I7. On L I8. On L it is I8. On multiplication I4. So on multiplication S4. On multiplication S4. On ID I5. On ID is I5. On ID is a S5. For ID is S5. Okay. S5, S4, 8, 7. Then what is the fifth one? What is the fifth state? The fifth state is dot and what is the production number? 4 is the production. So reduce production number 4 in both multiplication and dollar. In both multiplication and dollar, we are writing reduce the production number. Then what is sixth state? This is the sixth state. On R I9. On R it is I9. On L it is I8. On L it is I810. Right? I8 is same. Okay? 8 and both are same. So it is I10. Right? Then on multiplication I4. So shift 4 or shift 12. Okay. Then on ID I5. Right? Shift 11. Right? On ID. On ID shift 12. So here 9, 10, 11, 12. 9, 10, 11, 12. So here 8, 10 means it is 8. 11 means 4. Then 12 means 5. Then what is 7? The 7 is production number followed by dollar and assignment. What is the production number? Third production. Right? R3 in assignment and dollar. Reduce the production number 3 in assignment and dollar. Then, eighth production. Eighth state. Production dot end. Dot end means argument. Fifth production. Where we have to write dollar and assignment. Reduce production number 5. Reduce production number 5 in assignment column and dollar column. Then I9. What is the production here? First production. First production dot at the end followed by dollar. 9 in dollar place R1. it is all. I9 in dollar place, we write reduce the production number 1. So if we consider canonical LR table, they will be 13, right? They will be 13 states, up to 13 states. But in LLR passing table, it has only the 9 states. So LLR will have less number of states than the canonical LR. To construct LLR, we must construct CLR. We must construct canonical LR. For constructing the CLR only, we derive the LALR by combining the closure groups which are the same productions with a different locate symbols. So if there is no shift reduce, there is no reduce will result to the LALR grammar. So simply we say this is the LALR grammar. So this is the construction of the LALR passing table. So by this, I am closing this section. We'll discuss some more examples under the LALR in the next class. Okay? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.